I think this would probably be cubic centimeters instead of cubic inches, but this is one big soda can. 512 cubic centimeters would be 512 milliliters, which would be a reasonable. But 512 cubic inches, if you think a 1 inch, you'd have 512. If you drank that much pop, that probably wouldn't be very good for you. But anyways, here we have our can, and we know that the volume formula, right, because you memorized all those formulas for your related rate questions, so now you've still got them memorized. Volume is pi r squared times height. Pi r squared is a circle at the bottom, and if you just kept adding circles all the way up in the height, you'd fill the whole thing. So that's one way that I visualize that formula to help me remember it. And we know that the volume is 512. That's helpful because we want to have a minimum surface area. And so there's my surface area formula. Whatever you want the minimum of, that's the equation you need to write. So in an optimization question, if it says find the minimum surface area, I know that I'm going to have to write my surface area formula. Currently, what's the problem with my surface area formula? Is I have two variables. And if I have two variables, I'd have to use implicit differentiation and sort of make it like a related rates problem, which I don't want to do. So instead, I use the first information that was given to me and say I could rearrange this for one of the variables. And in this situation, when I looked at this formula, for me, it seemed a lot easier to get the h by itself than it was to get the r by itself. Because if you got the r by itself, you'd have to square root to get the plus or minus. Seems a little bit complicated. So I got h by itself, and now I can plug that h, circle it in purple here. Here's what h is equal to, and I just plug that in for h right there. That gives me an equation that's just in terms of the radius. It's actually kind of nice. The pi's canceled out. So how do we find a minimum of a graph? The derivative, set it equal to 0. So I find my derivative, I set it equal to 0, and use my skills in algebra to get r by itself. So what I did at this step right here is I multiplied everything by r squared to get rid of the r squared in the denominator. Cube root it, go to my calculator, 4.335. Add my units. We're dealing with inches here. All right, 4.35 inches, about there. That's the radius of my can. Oh, that is intense. But we could actually take a can. What is a can? How many mils in a can? A regular Coke can. 355. How many? Yours are not regular shaped. How many in there? So those cans there, and a regular can hold the same amount. One of them is using more aluminum. Which is better? I would tend to guess that the more standard can size has been designed to use less aluminum than this one. But that taller can size is like trying for a trendy, and they might be thinking that even though it uses a little bit more aluminum, they're hoping that the marketing features of that outweigh the extra cost of aluminum. But these are questions that businesses are asking, because if you could save Coca-Cola 0.1 cents per can of Coke that they make, how much money would that be worth to them? Right? It doesn't seem like very much. It's a tiny little change, but it could make them a lot of money. And if you come up with that, they'd be like, that idea is worth $1 million to us. Thank you, here's $1 million. I'm like, thank you very much. That would be amazing. Oh, do you remember these questions from grade 11? A rancher has 200 feet of fencing, of which to enclose 2 adjacent rectangular corrals. See the figure there? What dimensions should be used so that the enclosed area is a maximum? We've got a picture drawn there. You want a maximum area. So we're going to need to make a formula for area. And area is length times width, so 2x times y. Problem with our area formula is it has 2 variables right now. It has the x and the y. So what do we know? Well, if we add letters here, the total that we have is 200 feet. You would use 4 x's plus 3 y's to get there. Probably equally easy to get either x or y by itself. I happen to get y by itself. I can now substitute in where the y was, negative 4x plus 200 over 3. If you got this question in grade 11, you would multiply it out. Well, I can multiply it out anyways. Multiply it out and see that you get an x squared, which is a parabola. And you would just have to complete the square with the wonderful 8/3 and 400 over 3 as part of your question. And whenever you have fractions that made the completing the square that much more fun, I know. But now we can use calculus. If we want to find a maximum, we find our derivative. Set our derivative equal to 0, because then your tangent line would be horizontal, and that happens when you hit maximums or minimums. And because this is a parabola that's opening down, you know it would have a maximum. And it works out to a very nice number. X is 25. And if x is 25, then the width would be 50, or the length would be 50, and the width would be 100 over 3. So again, the big ideas of optimization questions. Whatever you want to optimize, find a max or a minimum of, that's the equation you need to make. And then we need to make sure that that equation is only in one variable so we can do our calculus with it. So let's look at the next question here. A rectangle is formed in quadrant 1 with one corner at the origin and the other on the line y equals 8 minus 2x. Find the largest area. A picture of what's happening here. 8 minus 2x would have a y-intercept of 0, 8, a slope of -2, So it would have an x-intercept at 4, 0. And you need to pick a point on that line and make a rectangle. And you want that green area to be as big as possible. Can you see that if I chose a different point, let's say here, that would make this rectangle? That area looks smaller. There's got to be a point somewhere on there that the area is the biggest possible. So we want to find the largest area. Area is length times width. But we have two variables here. Okay? Does it make sense that the y-coordinate is always 8 minus 2x? Because that's what y is equal to. Y is equal to 8 minus 2x. So I could write my point as x comma y, or I could write my point as x comma 8 minus 2x, because that's the formula for finding your y-coordinate. Doing that now changes my area to just one variable. Before we solve it, any guesses? You think it's right in the middle? You think it's at 2? 2 comma 4? Well, let's find our derivative. Set it equal. Oh, it is at 2. The maximum area would be 8. Why did they have to restrict this to quadrant 1? Can you see if we went into quadrant 4, it would just keep getting bigger and bigger and bigger? There would be no maximum if we kept on going. And our last question for today. A rectangle is formed with the base on the x-axis and the top corners on the function y equals 6 minus x squared. That is a parabola that's been shifted up 6 units. Draw a picture. And if I draw the picture, can I see that my area is going to be 2x times y? But what's our y-coordinate? Our y-coordinate is 6 minus x squared. Okay, I went with x equals 2 last time and I got it right. I'm going to go with x equals 2 again. Let's find our solution. Take your derivative. Set it. Oh, it was so close. X squared was 2. So your x value could be plus or minus the square root of 2, which means that this length is the square root of 2. Your y value is going to be 4. And the maximum area is 8 root 2. So the idea in optimization problems, if you want to find the maximum or minimum on a graph, That's always going to be where your tangent is flat. So you can find it by finding your derivative and setting your derivative equal to 0.